Hello class, this is a video tutorial on the integration of trigonometric functions part 2. So in this video we're going to look at integrating complex expressions, but before that we are going to be given some derivative, often involving the chain rule. We can integrate complex expressions related to the given derivative. Now the sorts of questions that we'll encounter with this are many, and there is no one way to do it. And in order to solve these questions, you'd have to have some intuition about you. So let's just do these two examples. Let's get straight to it. So first, let's find the derivation of sine to the fifth x. If it ever helps to solve these questions, you can treat these expressions as the following. So dx of sine x to the power of 5, like so. And this becomes 5 sine x to the power of 4 times the derivative of the inside of the bracket, which is cosine of x. Simplifying this, we get 5 sine to the fourth x cosine of x. Okay, so now let's do part 2. Now, because we know this integral here, this derivation here becomes this, take a look at how if we start at this point, we should come back to here. But notice what is missing, this 5. Okay, so if we treat this sine 4x cosine x dx, notice how it's so close to this expression here. It's just missing that 5. Well, how we can solve this question is, well, if we multiply by 5 and then divide by 5, if we multiply by 5 and then divide by 5, that is essentially multiplying by 1. Okay, well, because actually that's how we solve these questions. Now we have this expression here, and we know the integration of that is here. So this is going to become 1/5 of sine x, sine of x to the power of 5, except there's a plus c at the end because it's not a definite integral. Okay, so I hope that gave you a little quick insight on how to do this. Let's do another example here. Once again, we have tan raised 3 of x, and we're required to derive that first. If ever these are hard to interpret, once again, just think of it as tan of x to the power of 3. Applying the chain rule, we get 3 outside tan of x to the power of 2 times sec squared of x. Simplifying this becomes 3 tan squared x sec squared x. Now let's move on to question part 2. Notice how this expression is very close to this one. Okay, so let's write that out. Tan squared of x sec squared x dx. Now, once again, to solve this, we multiply by the missing coefficient, but at the same time we divide out that coefficient. Okay, now this gives us the expression that we have here. There's no need to think about what what that integral is, because we already have the starting point here. So this is going to be 1/3 of tan x raised to the 3 plus c, once again, because it is an indefinite integral. Right, so I hope that gave you an insight into solving complex integrals given a initial derivation. So hope to see you in the next video. Best of luck.